Okay, so good morning, dear students of IT 6208, System Integration and Architecture 1. Welcome to another virtual class today. So I am Miss Karen V. Lara, your OLC from AMA East Rizal. So before we proceed to our new topic today, let us first review what we have discussed last meeting. So we define what is data and information, the different types, classification, and characteristics of information. We also discuss what is a system, classification components and types and levels of information system, the various phases of system development life cycle or SDLC, concept of system modeling and system design, and the different types of UML diagram. So now we will be discussing another aspect of system integration and architecture. Let us first define what is software architecture. So it refers to the bigger structures of a software system, and it deals with how multiple software processes cooperate to carry out their tasks. It also serves as a blueprint for a system. It provides an abstraction to manage the system complexity and establish a communication and coordination mechanism among components. It is also the primary carrier of system qualities such as performance, modifiability, and security, none of which can be achieved without a unifying architectural vision. So the software architecture of a program or computing system is a depiction of the system that aids in understanding how the system will behave. And by building an effective architecture, we can identify design risks and mitigate them early in the development process. So the architecture of a system describes its major components, their relationships or structures, and how they interact with each other. Software architecture and design include several contributory factors such as what we have seen in the diagram. So we have the business strategy, the quality attributes, the human dynamics, the design, and IT environments. So let us define the different factors of a software architecture. So the first one, we have design, a plan or specification for the construction of an object or system or for the implementation of an activity or process. It is also the result of a plan or specification in the form of a prototype, process, or product. The design is the building of software application which displays the functionality of the product under development. We also utilizes various design tools and techniques to demonstrate the flow, the procedures, and algorithm of the software product. So we have various tools such as flowchart, we have input process output, we have the hierarchical input process output. We also have a data flow diagram and the various types of UML diagram. Next, quality attributes. It includes correctness, reliability, adequacy, learnability, robustness, maintainability, readability, extensibility, testability, efficiency, and portability. So these quality attributes are features that facilitate the measurement of performance of a software product. It will also enable software architects to guarantee that a software application will perform as the specifications provided by the client. So basically, these are the attributes that help the development team and the client to determine if you meet the requirements for a certain software or system. So I will be defining the different quality attributes that we have provided in the definition. So the first one is correctness. So it refers to agreement of product code with specifications. The correctness of a program becomes especially critical when it is embedded in a complex software system. The behavior over time for the fulfillment of a given specification depends on the reliability of the software system. Reliability derives from correctness and availability of a software product. The software can be seen as reliable if this test produces a low error rate, which depends on the frequency of inputs and on the probability that an individual input will lead to an error. While adequacy pertains to, for example, the input required of the user should be limited to only what is necessary. The software system should enable flexible data input on the part of the user and should carry out plausibility checks on the input. While learnability of a software system depends on the design of user interfaces and the clarity and simplicity of the user instruction. Interfaces must be easy to use and easy to navigate um, by the end users or the client. And there must be a user manual which should explain to the user what the software system should do. The robustness reduces the impact of operational mistakes, erroneous input data, and hardware errors. We sometimes commit frequent errors like erroneous commands or typing errors, such as, for example, syntax error, which must be handled with care. So another example is less frequent errors like power failure that can be handled more laxly, but still must not lead to irreversible consequences. Next, we have maintainability, refers to the suitability for debugging, correction of errors, and for modification and extension of functionality. Maintainability also pertains to, aside from omitting errors inside the program, we also perform maintainability in order to add features or components into the software system. Readability depends on the software system's form of presentation, programming style, consistency, quality of the documentation, or structuredness of the system. Extensibility allows required modification at the appropriate location to be made without undesirable side effects. Testability is allowing the programmer to follow program execution and for debugging. There are various testing tools that must be used in the software code to reduce the testing effort and provide systematic testing of all system components. So we have various types of testing that can be used, such as unit testing, module testing, performance testing, robustness testing, and the like. Next, we have efficiency, which is the ability of the software system to fulfill its purpose with the best possible utilization of all necessary resources, such as time, storage, transmission channels, and peripherals. Lastly, portability is the ease with which a software system can be adapted to run on computers other than the one for which it was designed. Next factor is the IT environment. So an integrated collection of technology components that serves the needs of its users and the owners of the resulting system. So IT environment also provides policies and procedures that the entity implements, and IT infrastructure like hardware, various operating system, various application software that is uses to support business operations and strategies. Next factor, we have the human dynamics, a team-oriented activity involving engineers, developers, business analysts, domain experts, data infrastructure architects, or project managers. So, software systems are fundamentally solutions designed by humans for humans. So developing a system is inherently a team-oriented activity involving those members of the development team. And the last factor is the business strategy, which refers to the actions and decisions that a company takes to reach its business goals and be competitive in its industry. Business strategies also defines what the business needs to do to reach its goal, which can help guide the decision-making process for resource allocation. Now let's proceed with software design. So it provides a design plan that describes the elements of a system, how they fit and work together to fulfill the requirements of the system. The objective of a design plan is or are as follows: to negotiate system requirements and to set expectations with customers, marketing, and management personnel, act as a blueprint during the development process, guide the implementation tasks, including detailed design, coding, integration, and testing. So it comes before the detailed design, coding, integration, and testing, and after the domain analysis, requirement analysis, and risk analysis. So in this diagram, it demonstrates the flow of the software design of a certain system or software. So we have here a domain analysis, requirement analysis, and risk analysis. The domain analysis is the process of analyzing related software system to find their common or variable parts, while requirement analysis determine user expectation for a new or modified product. So sometimes we are asked to create or develop a new system for a certain company, and sometimes we are asked to modify or enhance an existing system wherein we can only add new components or new elements inside the system. The technique used to identify and assess factors that may jeopardize the success of a project or achieving a goal is a risk analysis. So we have here requirement desired quality, and then we have the software architecture design, which refers to the fundamental structure of a software system. We have the hardware architecture design, which is the identification of a system's physical components and their interrelationship. So hardware architecture design is how we design the physical components or physical elements of a certain software system. And then next, we have the system can be modified based on the requirements asked by the client. We can also modify the hardware. Either we embed a new technology inside the system, or we upgrade the physical requirements of the existing system. And then we have here the implementation, wherein we perform the detailed design of the system. We select the appropriate programming language for the coding. We integrate it, meaning that one module can communicate with another module, and then we test the software if there are some errors or glitches inside the program. So what are the goals of architecture? So expose the structure of the system but hide its implementation details. Realize all the use cases and scenarios. Try to address the requirements of various stakeholders. Handle both functional and quality requirements. Reduce the goal of ownership and improve the organization's market position. Improve quality and functionality or offered by the system, and improve external confidence in either the organization or system. So basically, these goals of architecture involves the development team and the users or beneficiaries of the proposed system or the software or system to be developed by the development team. So what are the different limitations of the software architecture? So these are the boundaries of the software architecture. So lack of tools and standardized ways to represent architecture, lack of analysis methods to predict whether architecture will result in an implementation that meets the requirements, lack of awareness of the importance of architectural design to software development, lack of understanding of the role of software architect and poor communication among stakeholders, and lack of understanding of the design process, design experience, and evaluation of design. So we have to take note of these limitations in order for us to come up with a functional and efficient system software. So what are the different roles of a software architect? So the first one is design expertise. So leading the development team and coordinate the development efforts for the integrity of the design. Um, he or she is also an expert in software design, including diverse methods and approaches such as object-oriented design and event-driven design. Next, domain expertise, expert on the system being developed and plan for software evolution. So assist in the requirement investigation process and assuring completeness and consistency of the software system. Next, technology expertise, expert on available technologies that helps in the implementation of the system. He or she coordinates also the selection of programming language, whether it is, for example, a LAN system, a system that will be web-based. So the various programming language, the various scripting language that will be used, as well as the different hardware and software requirements that will be needed for the software. He or she is also responsible for the framework of the software system, the platforms to be used, and the design of the databases. Methodological expertise is an expert on software development methodologies that may be adopted during the software development lifecycle or SDLC. He or she also chooses the appropriate approaches for development that helps the entire system. So this expertise may also use various model aside from the SDLC, such as the agile, the iterative or incremental, the rapid application development, and other models that can be used or appropriate for a software system to be developed. So we have here the common qualities attributes. So the first column is the category. The second is the quality attributes and the description. So design qualities is the value of a design to customers. It is the root of all quality like products, services, experiences, systems, and processes. So the design quality have the following attribute. Conceptual integrity, which defines the consistency and coherence of the overall design. Coherence pertains to the oneness of the design of the software system. This also includes the way components or modules are designed. Next, maintainability, ability of the system to undergo changes with a degree of ease. So whether, for example, you wanted to add features or add new components inside the system. Next, we have reusability, defines the capability for components and subsystems to be suitable for use in other applications. Next category, we have runtime qualities. So the runtime qualities can be measured as the system executes. So we have interoperability, ability of a system or different systems to operate successfully by communicating and exchanging information with other external systems written and run by external parties. Manageability defines how easy it is for system administrators to manage the applications. Reliability is the ability of a system to remain operational over time. Scalability, ability of a system to either handle the load increase without impacting the performance of the system, or the ability to be readily enlarged. Security, capability of a system to prevent malicious or accidental actions outside of the design usages. Performance is the indication of the responsiveness of a system to execute any action within a given time interval. Availability defines the proportion of time that the system is functional and working. It can also be measured as a percentage of the total system downtime over a predefined. So next we have the system qualities. This can be used to describe and document a system. So we have supportability, ability of the system to provide information helpful for identifying and resolving issues when it fails to work correctly. So supportability is very important because it also assists the end users for some of the issues like how to run the program, how to install it, how to generate, for example, reports. So that's why supportability is an essential part of a software architecture. Next, testability measure of how easy it is to create test criteria for the system and its components. User qualities is to design products that satisfy their target users. Usability defines how well the application meets the requirements of the user and consumer by being intuitive. Architecture quality can open concept built on knowledge. So we have correctness, the accountability for satisfying all the requirements of the system. Next, we have non-runtime quality. So this cannot be measured as the system executes. So we have portability, ability of the system to run under different computing environments. Integrity, ability to make separately developed components of the system work correctly together. Modifiability is with which each software system can accommodate changes to its software. And we have the business quality attributes, which is a property of a work product or goods by which its quality will be judged by some stakeholders, end users, or other beneficiaries of the software system. So we have cost and schedule. Cost of the system with respects to time, to market, expected project lifetime, and utilization of legacy. Marketability is the use of the system with respect to market competition. So now we'll proceed with architectural style. So the architectural style is also known as architectural pattern, a set of principle which shapes an application. It also defines as an abstraction framework for a family of system in terms of the pattern or structural organization. Architectural design or style is also responsible for providing a lexicon of components and connectors with rules on how they can be combined. It also improved partitioning and allowed the reuse of design by giving solutions to frequently occurring problems. They also describe a particular way to configure a collection of components, a module with well-defined interfaces, reusable and replaceable, and connectors, communication link between different or various modules of the software system. The architectural style is also known as a topological layout of the components indicating their runtime interrelationship. So what are some of the common architectural design? So we have the first column category, architectural design and its description. So the first category is communication. So message bus prescribes use of a software system that can receive and send messages using one or more communication channel. SOA, or Service-Oriented Architecture, defines the applications that expose and consume functionality as a service using contracts and messages. Next category, we have deployment, client-server, separate the system into two applications where the client makes requests to the server. The three-tier or N-tier separates the functionality into separate segments, with each segments being a tier located on a physical separate computer. We also have domain or the domain-driven design focuses on modeling business domain and redefining business objects based on entities within the business domain. We have structure, component base, break down the application design into reusable functional or logical components that expose well-defined communication interfaces. We have layered, divide the concern of the application into stacked groups or layers. Object-oriented, based on the division of responsibilities of an application or system into objects, each containing the data and the behavior relevant to the object. So, what are the different types of an architecture? So we have the business architecture, which defines the strategy of business, governance, organization, and key business processes within an enterprise and focuses on the analysis and the design of business processes. The business architecture also is a discipline that represents holistic, multi-dimensional business views of capabilities, end-to-end value delivery, information and organizational structure, and the relationships among these business views and strategies. An example of a business architecture is an enterprise mission, an enterprise vision, its strategy and goals. Next type is application or software architecture. So it serves as the blueprint for individual application systems, their interactions, and their relationships to the business processes of the organization. So the application software architecture map of how an organization's software applications are assembled as part of its overarching enterprise architecture. It also demonstrates how they interact with each other to meet business or user requirements. Example of this type of architecture is a layered pattern which is used to structure programs that can be decomposed into groups of subtasks, particularly applicable to general desktop applications or e-commerce web applications. So by the way, e-commerce web applications, those are buying and selling online applications. Next type of architecture is information architecture. It defines the logical and physical data assets and data management resources. It is also the structural design of shared information environments, example of which is organizing and labeling websites. So the last type of architecture is information technology architecture. It defines the hardware and software building blocks that make up the overall information system of the organization. So a detailed description of the various information processing assets needed to meet the business objective. Example of which is a web-based information technology architecture of an academic library. So next we have architecture design process. So these are the various stages of an architecture design. So we will start with understanding the problem. So this is the most crucial step because it affects the quality of the design that follows. Without a clear understanding of the problem, it is not possible to create an effective solution. So understanding your problem, basically, we are trying to analyze what must be done into the software system or what are the requirements to be used inside the product. And in this process also, many software system products are considered failure because they did not actually solve a business problem. So the second process is identify design elements and their relationships. So in this phase, build a baseline for defining the boundaries and context of the system, the composition of the system into its main components based on functional requirements. That's why it is very important also to identify the hierarchy of the different modules, submodules, and components of the system. So the decomposition can be modeled using a design structure matrix, which shows the dependency between design elements without specifying the granularity of the elements. So if all the estimated in this step, the first validation of the architecture is done by describing a number of system instances. So evaluate the architecture design. So each quality attribute is given an estimate. So in order to gather qualitative measures or quantitative data, the design is evaluated. So it involves evaluating the architecture for conformance to architectural quality attributes requirements. So if all the estimated quality attributes as per required standard given by the end user, the architectural design process is finished. If the observed quality attribute does not meet its requirements, then a new design must be created. Next is transform the architecture design. So this step is performed after an evaluation of the architectural design. The architectural design must be changed until it completely satisfies the quality attributes requirements. So it is also concerned with selecting design solutions to improve the quality attributes while preserving the domain functionality. So a design is transformed by applying design operators, various styles or patterns. The design is again evaluated and the same process is repeated multiple times if necessary. So we have here a list of key architecture principles. So these key principles can be considered while designing an architecture. So the first one is build to change instead of building to last. The application may need to change over time to address new requirements and challenges of these challenges coming from the end users or the beneficiaries of the software system. Next is reduce risk and model to analyze. Use various design tools, visualizations, modeling systems such as the UML or the Unified Modeling Language that we have learned last meeting. These design tools are used to capture requirements and design decisions. Use models and visualizations as a communication and collaboration tool. So use models, views, and other visualizations of the architecture to communicate and share the design efficiently with all the stakeholders or end users. And the last one is use an incremental or iterative approach. So start with a baseline architecture and then evolve candidate architectures by iterative testing to improve the architecture. So we have here key design principles for software architecture. The first one is separation of concerns. So divide the components of system into specific features so there is no overlapping among the components' functionality. Single responsibility principle. Each modules of a system should have a specific task which helps the user to clearly understand the system. Next is principle of least knowledge. So this approach avoids interdependency and helps maintainability. Next, we have minimize large design upfront. Utilize this principle if the requirements of an application are unclear or vague. If there is a possibility of modifying requirements, avoid making a large design for the system. Next is do not repeat the functionality. So duplication of functionality within an application can make it difficult to implement changes, decrease clarity, and some potential inconsistencies. Next, prefer composition over inheritance while reusing the functionality. So this principle provides a great level of freedom and reduces the inheritance hierarchies. Identify components and group them in logical layers. So this principle will satisfy the requirements in each area of concern needed in the system. Define the communication protocol between layers. Understand how components will communicate with each other, which requires a complete knowledge of deployment. So by the way, deployment is also a method of releasing the software product to your end users or clients. So during deployment, we may also encounter various errors which must be fixed by the software development team. Next is define data format for a layer. So this principle reduces processing overhead. So do not mix the data formats so that applications are easy to implement, extend, and maintain. Next, we have system service components should be abstract. So code related to security, communication, or system services like logging, profiling, and configuration should be in a separate components. So next is design exceptions and exception handling mechanism. So this principle helps the components to manage errors or unwanted situation in an elegant manner. And the last key design principle is naming conventions. So it is easier for team members to validate code written by others, thus increases maintainability. So the software architecture and system design have various methods and practices that can help organizations use software architecture to build and evolve systems that satisfy their business and mission goals. So we will go back the with this one, the common quality attributes. So as your task, you are going to provide an example for the various quality attributes that I have provided here. So you are going, under the design qualities, you are going to provide an example of conceptual integrity. The description is already given here. An example of how you conduct maintainability, reusability, and other attributes. So basically, these attributes are being used for getting some feedback from the end users or stakeholders. So we uses these attributes in order to determine if we meet the user requirements or if the system will be usable or will be deployed. So for your task, you are going to provide an example for each of the attributes. So we have under the design qualities, provide an example of conceptual integrity, maintainability, reusability. For the runtime qualities, provide an example for interoperability, manageability, reliability, scalability, security, performance, availability. Under the system qualities, you also provide an example of supportability, though I have given already an example a while ago, and testability. User qualities for usability, architecture quality for correctness. And for the non-runtime quality, you also provide an example of portability, integrality, modifiability, and for the business quality attributes, the costing schedule and marketability. So you are going to send that to me on my email. So kvdelara@amaes.edu.ph. So you are going to provide an example for each of the attributes that I have discussed, and you are going to submit that on or before our next meeting. So I would like also to thank everybody for attending and listening to our virtual class today. And then I will be posting this notes or these lectures in our LMS for your references.